Welcome to another GUI screencast. In this screencast I just wanted to show from start to end an example of perhaps a more complicated problem. So what we have here is going to be a plotting window, and it's going to plot a polynomial. So Bronson covered this in his lecture notes, and if you dig that up you can find what I mean, but otherwise just bear with me and I'll show you what I'm going to do. So first thing I do is I'm going to set a default value for the window created by MATLAB. So my figure is going to be 800 by 600. I'm not sure the X and Y do anything useful, but I'm going to set them to 0 anyway. This will do for now. I'm going to kind of rush through this example because I intend not to pause, and I just want you guys to see a start to end example. And you don't have to sit through the entire thing, you can just jump to any stage that you like. So my first object will be a plotting window. I might make it that big. I'll have a slider bar to control the range of X, and I'll have another for the slider for the range of Y. I'm going to have static text box maybe here, and that's going to display my polynomial. And I'm going to have edit text boxes down here, and all they do, they control the polynomial values. So for a start I might just make it a quadratic. Quadratic only needs the first three edit boxes, one for the coefficient of x squared, coefficient of x, and the constant coefficient. So this fourth one here I might use later. So the first thing you should do after laying out all of these objects in your figure is you should save your progress at all times, or try to. So I might call this polyplot. Save your progress at all times. Then the next thing you should do is rename the tags. So give them something sensible. So I might call this plot window. That's fine for now. This can be my slider X. This can be my slider Y. This can be my I'll say polytext. Now for the coefficients, it's convenient to just call them something like edit A for the coefficient A, edit B, edit C, and edit D. So I'm not too worried about the default values for now. I just want to dive in and get some code working. So what should we do if we want to get this to plot right at the start? You can come to this function here, the opening function. So when the figure is created, it says executes just before polyplot is made visible. So polyplot is the entire figure. Yes, polyplot.fig, and this controls what we see when the figure is created. So I can make an X vector like we've done many times before. I'll just go from 5 to 5. I'll plot X against X squared, and I'll put a grid on as well. So if I run that, there's my plot. It's a little bit of black magic how MATLAB knows to talk to this plot window, seeing as I didn't use any sort of object to do that. But there you go, it's nice and easy for you. And obviously the slider bars aren't going to do anything yet because I haven't told them to. So close that. Now what I'm going to do is get my sliders working. So what we can do is pull out the value. So the value is going to be, as per the hint here, this returns the position of the slider. I will get h object value, and that's going to be a numeric value from 0 to 1. I don't want it to be from 0 to 1, rather I want my plot dimensions to be from -5 to 5, and if I adjust this it might zoom in to -1 to 1. So what I can do is go to my X slider, and you'll see here it has a value of 0 by default, and its minimum value is 0 and its maximum value is 1. I'll change this range to be from 5 to 1, and I'll make its default value 5. So that this means the range is going to be from 1 to 5. Okay, now I'll do the same for the Y slider. Maximum value of 5, minimum value of 1, and the default value. I'm sorry, this is for x squared. I might make this 50 actually. Maximum value of 50, million value of 5. Okay, so that my sliders are set up. If I open MATLAB up again, what do I need to do now? I've got my value. Now I want to set the ranges on the figure. So I come to my plot window, and you have a value here called xlim. So the first value is going to be the minimum value, and y is going to be the maximum value. So when I created the plot for the first time, MATLAB automatically generates the x limit for you, but by default this is 0 to 1. So I might go ahead and code up what we want it to do. That's fine the way it is. I don't need to change that default, but what I'll need to do is now set handles.plot window its key xlim, and I'll set the minimum of the x limit to be negative value, because value is the value of the slider bar, to value. So if my maximum value determined by the slider here, my maximum value is 5, that means that the plot should be from -5 to 5. -5 to 5. If my slider bar is 1, then it'll be from 1 to -1. So hopefully that makes sense. That should work nicely. Now I do the same for the Y. So this will be Y limit, and that should work. Let's have a look. And there we have it. Pretty easy. You'll notice that if I bring this slider back up to the top, that it's been permanently changed. Just to demonstrate, I'll run this again. The Y limit is from 0 to 25, but if I change this, it goes from -50 to 50, because that's what I specified. So maybe I want to make this the default value rather than from 0 to 25. So I just come back up to where I'm at a plot, use the axis command, and the axis command works by setting the minimum x value, the maximum x value, the minimum y value, and the maximum y value. So now if I try this again, it looks like that right at the start. Now when I adjust this, it goes back to the way it was. So it's working. Alright, now let's get each of these text boxes playing with the polynomial. So you'll see I've got an edit A callback, edit B callback, and edit C callback. Every time I want to edit one of these text boxes, the plot should be updated. So actually what I'm going to do is make another function in here. I'll call it function update plot. It'll take in an input of handles. So whenever I run this function, it should be passed an input of the handles, and these handles is fine. So what I'll need to do then is get the value of the edit box A, edit box B, C, and D. Won't worry about D for now because we're only concerned with quadratics. So I'll just say A is get handles dot edit A, and what am I getting from edit A? I'm getting the string, as you can see here. Remember that it's a string type, not a number type, so I'll need to convert this with string to num. And that's how I get the value of A. Do the same for the rest of them. Sorry. B, C, and D. I'll just put D in there anyway, seeing as we'll use it later. And there's each of those. So now all I need to do is generate my X range again. What I used up above will not be preserved. That's a separate function. So we plot X against A times X squared plus B times X plus C. That'll do for now. Grid on, and the axes probably should be reset as well. So I'll make this from -5 to 5, -50 to 50. And if I'm going to do that, I'll need to reset the sliders back to their maximum values as well, so that these maximum values are honored. So if I run this now, I don't get any errors. It's interesting. So that doesn't seem to work. Okay. So a theory why that might be is because these edit boxes actually have strings in them for a start. So I'll change the default strings to be actual polynomial coefficients. So this one should be 0, because I just want y equals x squared for a start. 0 and 0. Run that. I'll change this. Still doesn't work. So what else could be the problem? We're getting no error from MATLAB itself. The problem is that the edit callback isn't actually calling this update plot function. So all I need to do is actually run my constructed function, and I'll input into it handles, which has been input when we run this callback. Obviously we'll need to do this every time we update any one of these edit boxes. So leave the create functions alone, they're fine as they are. We want to run just these. So if I change that, there we go. You'll notice that if I reduce this to -1 to 1 and I change this back to 1, the axes have been changed, but the slider bar is still in its position here. And of course it'll still work when I adjust it, but that's probably not what we want. So as I mentioned earlier, we'll need to reset each of those. So I'll set handles dot slider x, its value to its maximum value, which was 5, and I'll copy this. Slider y value of 50. So now if I adjust my slider bar, that works as expected. If I make that 3, it's been set back to maximum values, so that's good, that's working. So now I should be getting polynomial plots that are accurate, and that seems to be the case. Okay, static text. So it'd be nice if we could put into here the actual polynomial being plotted. So by default, when we run this, we get y equals x squared. So I may as well go into the figure and edit the static text object to have y equals x squared. Obviously this doesn't change anything, it's just the text. I'll change its default text size to be a bit bigger, font size. Let's try 20. That's okay, that'll do. This is, you know, I'm not trying to make this very neat right now. It's meant to be demonstrative. So obviously when I change this, the text won't be updated because I haven't written any code to do so. So let's go back into MATLAB. Update plot is what we're interested in. Now, I'm going to make a variable. I'm going to call it polystring. And for a start, it's just going to say y equals. So depending on the values of the coefficients, I'd like to be able to display them. So if a is equal to 0, then we shouldn't do anything. So I'll say if a is not equal to 0, then what we can do is concatenate y equals with a and times x squared. So what I need to do now is determine a function that might concatenate. So I'll go into my help browser, search for concatenate. That's not exactly what I want. Horizontal concatenate looks like a winner. Okay, so hors cat, if I test this with just a couple of text strings, there it is. So that's what I want. So what I'll do is plot string is equal to horizontal concatenation of plot string with a. I'm not sure if it'll handle. What I can do is convert it to a string, and then I'll have there, did I use a star? I haven't used the symbol yet, so I'll use just an x for multiply. I can't do that because I'm using x's as my variable, so I'll use multiply x squared, and I'll put a space trailing on the end as well, and that. So let's just see if this works. Actually, I'll need to talk to the object I'm updating, of course. So set handles dot, I've forgotten what the object's called. The object's called polytext. The value string with plot string. Okay, let's see if it works. Unbalanced parentheses. I forgot my closing bracket. So we'll change that to 3. And that works. Very cool. I probably also want a condition in here that if it's equal to 1, that don't bother displaying it. So let's do that now. Else if a is equal to 1, actually what I'll do here, yes, all I need to do is say plot string equals horizontal concatenation of plot string with x squared. Okay, basically copy this code for the B and C case. This doesn't apply. X squared doesn't make sense for just the x coefficient, and all I should need to do is concatenate the constant, which is C here. That's B. Before I attempt to debug this, I might just run it and see if it works. Right, so it's put a space there, but I need to put a plus in. And if I do that as well, that works nicely as well. Cool. If b is equal to 1, interesting. Okay, so let's put, no, we put that in here, plus symbol, and a space at the end. I could just put a plus plus there, plus in there. Let's see what's missing when we run this. So that looks pretty good. I want to get rid of this 1 times here though. Why is that occurring? Because I have if b is not equal to 0, else if b is equal to 1. Yes, so this condition is never met because if b is equal to 1, this condition is true, so this condition is never run. So what I should do instead is say b is equal to 1 here, and I have to swap the code around. So make that easier, I might just move this down here. Okay, let's try that now. I'll make that negative. It'll display like that, which is fine. Great. Okay, so we have a fairly basic polynomial plotting program here. Excellent. So it'll get a little bit more tricky if I try to include D, so I might leave that for another screencast.